We're going to start with chemical equilibria. And now in now in chemical equilibria, remember that just a brief idea of what used to happen in AS. Okay, just a bit of practice of AS. Now in AS, you study that when a reaction is at equilibrium, uh, the reactants are turning into products, and the products are turning back into reactants at the same speed. The rate of forward reaction and the rate of backward reaction are equal. So the net change in the quantity of reactants and products I mean, there's not going to be any net change. So it's going to be an equilibrium reaction. And Kc was equilibrium constant was it was the concentration of the products divided by the concentration of the reactants. Okay, this is what Kc was. And you were asked to write expressions for Kc. For example, if you have a reaction, there's N2 reacting with H2 and it's in equilibrium with 2NH3. So Kc was simply the concentration of NH3 squared divided by the concentration of N2 and H2 cubed. So this is what Kc was, and you were supposed to give the units for Kc, which is that in this case it's going to be concentration squared divided by concentration into concentration cubed. So the answer would come out to be x to the power minus 2, and x was concentration, which is mole per dm cube. So it's mole minus 2 and dm 6. So this is what the value of or the unit of Kc was. And you would get a few types of questions. The first question would be that you'll be given initial moles. So they're going to draw a table asking you or giving you initial moles. So let's draw a table quickly. So now this is how the table would look like, and they would give you not as a table actually. They would give you a reaction. For example, in our case, it's N2 and H2 reacting to produce NH3, and they'll offer us some insight about what's going on. So you have your NH3, you have your H2, and you have your N2, and they would give you some insight about your initial amount of moles that are added to the container. So let's say, for example, initially 0.8 moles of this and 0.8 moles of this and 0.6 moles of NH3 are added into the container. Then they would give us some hint about how many moles after several days, when you have mixed them together, the reaction goes in forward direction and it also goes in backward direction. And eventually, a point would come when the rate of forward reaction equals the rate of backward reaction, and they reach equilibrium. Now, at equilibrium, the moles would be different. So, for example, there should be a 2 over here. So, for example, the moles of an NH3 at equilibrium are coming out to be 0.8. So, how can I figure out the moles of the other reactants at equilibrium? So, these are my equilibrium. I said these are my equilibrium moles. Now, if you had added zero point 0.6 moles initially, and at equilibrium you have zero point 0.8 moles, that indicates that the difference is that 0.2 moles they got produced. I mean, now के start के अंदर you had added zero point 0.6 moles, but after several days when you found out and you checked, there were zero point 0.8 moles present. So that means 0.2 moles extra produced were. Now to produce 0.2 moles extra, you need to react 0.3 moles. कि अगर 2 moles NH3 produce होंगे, तो at this end 3 moles H2 would react. So if you have 0.2 moles getting produced, then over here 0.3 moles would react. And similarly, if 2 moles are getting produced, then 1 mole is getting reacted of N2. So if you have 0.2 moles getting produced, the 0.1 moles would be, according to the ratio, 0.1 moles must have reacted. तो स्टार्ट के अंदर आपने कितने डाले थे 0.8 मोल्स, उनमें से रिएक्ट कितने कर गए 0.3 कर गए, तो पीछे कितने रह गए 0.5 मोल्स. इधर स्टार्ट में कितने डाले थे 0.8, उनमें से रिएक्ट कितने कर गए 0.1, तो पीछे कितने रह गए 0.7 moles. So always remember that concentration is used and you're going to divide the moles by the volume, which is 2 dm cube. Anyways, moving forward, what would be the expression for Kc? Kc would be NH3 concentration squared, so it's going to be 0.4 squared, and the whole thing would be divided by 0.35, which is the concentration of H2, and multiplied by the concentration of not H2, this is the concentration of N2, multiplied by the concentration of the other reactant, which is H2 in this case, so it's going to be 0.25, but that would be cubed. Quickly tell me what the value is. So in this question, you have your initial moles, you have your equilibrium moles, and middle minor reacted produced. Okay, how many are getting reacted? How many are getting produced? So try and fill this table up based on the data that's given. TK Cl2 is also 0.2 moles and HCl is 0.6 moles. आयशा क्या है आपका? महफूज कुछ बना है इसका आंसर है कोई?
सर मैं भी कह रहा हूँ.